Hey guys, today we're going to talk about parametric equations, and we're in the same chapter of vectors, and this is like going to be the next part. So let's get started. So with parametric equations, what's going to happen is this: where normally we have a point x y. So let's say we have a point x y, and this is some relation. Could be a function. Could not, might not be. And what's going to happen is we're going to add another variable to this problem called a parameter. So we're going to take this point and we're going to change it, and we're going to define each one of these as its own function. So the x value will have some function, let's call it f of t, and we use t for time in these problems. And the y function, I don't want to use the same function as f of t because you always get the same numbers. It's going to be some different function. We'll call it g of t. T is my parameter. So the variable t is the parameter. And so what we're going to do with this is we're going to take problems, define functions, or have functions given to us, either change them to parametric or change them back to normal or um, rectangular equations. So let's take a look at an example. So number one, I have an example. xy is defined by x is t plus 1, so that's the function, and y is the function t squared plus 2t. These are called the parametric equations. All right, so let's go through. T is the parameter. An equation with t's in it are called parametric equation. Notice there's two of them. So what we're going to do is we're going to set up a chart. So I have t, I have my x value, which is t plus 1. I'll have a y value, which is t squared plus 2t. And at the end, I could put them back together as a point, like how we normally see them, as x plus 1. So let's just do a couple of values here. So for example, let's just pick like -2, -1, 0, 3. So for these certain times or t values, or we're going to do them by steps, I'm going to find the values. So for example, so x equals -2 plus 1. So -2 plus 1 is -1. So that's the x value. So over here, it would be -1 something. Well, let's plug in -2. So I'm not going to do every single one. I'm just going to look at -2 squared is 4. 2 times -2 is -4. So that's a 0. So the first point is -1, 0. Why don't you try the next couple? Those are my x values. -1 squared is 1. 2 times that is -2. That's a -1. 0 squared, 0 is 0. 9 plus 6 gives me 15. So these are my y values. So these parametric equations gave us these points, which I can graph normal now. Now these are like normal points. Your calculator will do this also. So, for example, let's turn on the calculator. Now, this is going to be different. We have to change the mode. So, we have to change the mode. So, if you notice right here, next to function, it says PAR, and that stands for parametrics. So now when I press y equals, they give me the spots for the x, y. So the x is a function of t, y is a function of t. And so let's go in. We can punch in this first one. So go to x1, and we got t plus 1. And notice that the button x, t, theta, n that we normally use, the t is for the parametrics. So I press t plus 1. Go down to the next one, t squared plus 2t. And then what we could do is I could go to my table, and notice how they give it to us. So now my first number on my table was negative 2. So let me just go up a little bit to negative 2. And notice it's negative 2. The x value is negative 1, y is 0. And so actually it will generate these values for me. All right. So what if they give us the functions and they're like, you know what, get rid of the letter t, just give me the normal equation. This represents some normal equation, so let's do that part. So this is what they call eliminate the parameter, and what they want us to do is to get the regular equation. So now it's not really called a regular equation. It's a rectangular xy, you know, so or just x and y's. They don't want. There's no parameter t. Okay, so now remember, t is the parameter. If you have t's in the equations, they're called parametric equations. If I just want the x and y, those are my rectangular equations. So let's write down those equations we just had. So we had x is t plus 1, and we had y was t squared plus 2t. All right, so the goal is this. Now, this is y. I want y equals. That's how we like it usually, y equals. So what I want to do is I want to get t by itself over here. So I want this t by itself. And what I'm going to do is I'm going to plug it in for these t's. So for example, what we could do is if I move the 1 over, so t is x minus 1, and it's a substitution problem. We're going to plug in to these problems. So I have y equals x minus 1 squared plus 2 times x minus 1. You're going to need to expand that out and distribute this. Why don't you try it? Now, don't be lazy and say x squared minus 1 or x squared plus 1, all right? You FOIL it out, you distribute it through, double distribution. So this is x squared minus 2x plus 1. Distribute this part, we get 2x minus 2. Clean this mess up, and my regular equation, my xy equation or my rectangular equation, is called, so the x's, 2x's cancel, so I get x squared minus 1. Now, if I go to my equations here, let's get rid of this. Go back to regular mode for a second. You don't have to do this. Just follow what I'm doing. I could type in x squared minus 1, and when I go to my table, I get the same values I had before, negative 1, 0. 0, negative 1, what other ones we used? 4, 15. So this is how I know this is correct. Last part you have to be able to do is graphing parametrics. So let's try that. All right, so let's try a new equation here. So let's try x equals t squared minus 1, t squared minus 2, and y equals 3 times t. Now, these are t's, those are my parameters. The equations would be called parametric equations. And now I want to graph these over a certain interval. So now we have something. Now we have something different. We have an interval. So we're going to graph over different intervals. And let's see what happens. And this interval we call I. That's how our text defines it, I. And it's called the parametric interval. So for example, let's do the first one. Call this A. I want to graph it for -3 less than equal to t less than equal to 1. Because what's happening is I'm plugging in t values, it's generating x values. Depending on what t values I get, it gives me different x's. So let's enter the equations. So we got t squared minus 2. And 3t. And right now, if I just hit graph, you don't know what that is. It looks like it's, I don't know, rad function or a piece of a parabola or something, sideways. Press window, because now I'm going to put my interval. Now, here's where I put my interval. The t minimum in this problem I have to start with is -3. So we put -3. T maximum for this problem is 1. The t step, don't worry about that for now. It's just how often is it calculating these values for the graphs. If you change this value to something really big, you get kind of like zigzaggy lines. So don't mess around with it too much. And the x and y is my normal windows. So now let's hit graph. So when I plug in these values, so for example, when I plugged in -3, like we did in the original example, what we could do is, figure out this value. So -3 would give me x's, so that's 9 minus 2, that would be 7, and -9. So I'm over here, I'm down here, 7, -9. So 1, 2, 3, 4, 5, 6, 7, and I'm just going to eyeball this a little bit. And I could calculate the values that way. Or we're just going to look at this graph and we're going to say -1, and it's about 1, 2, 3. And it crosses here at -2. And 4.5, 5. So this is what I'm looking at. We're not going to, you stop at those points. Now yours hopefully looks a little nicer. It's a little tricky to draw with this pen. You stop at those points. Just stop. Don't go through it. Don't go past. That's a little banged up looking. Let's try it again. Change the interval. -2 to +3. Alright, so that's my new parametric interval, I. So I press window. So we change it -2 to 3. Alright, now that gave me a different part of this graph. So the way we calculated it just gives you a different part. So 2, 6, something like this. Still cross here. Now these points should be still the same points. It's just now we have a different section of the graph. Like this. And this one just keeps going up like this. And last one, -3 to 3. And that's going to actually just give us a nicer graph. And this is a parabola. It's a sideways parabola. So, and that's about it. Now, the scale of my drawing is different than the scale here. Notice mine are symmetric. Remember, this is what we were talking about. This is not this is not even intervals. So these are closer. The y-axis is closer. So that's why you get a little stretch looking thing going on. All right. Thanks, guys. I'll see you tomorrow. Bye.